Next method is least cost method. In this method, allocations are made on the basis of unit transportation costs. The method is explained below. Step 1. Select the cell with the least unit transportation cost and allocate as many units as possible to that cell. Step 2. If the minimum cost exists in several cells, select a cell arbitrarily and assign the possible number of goods. Then consider the remaining cells of the same unit transportation cost. Step 3. Select a cell with the next higher unit transportation cost and continue the process till all requirements are met. You can see an example. Find the initial feasible solution of the problem given below by least cost method. Table is shown here. From the given table, the total number of supply constraints equal to 3, total number of demand constraints equal to 4, and sigma Si equal to sigma Dj. That means the given problem is a balanced transportation problem. The problem table is shown here. From this table, see the smallest transportation cost, which is 8, that is in the cell S3D2. Then we can allocate the value to this cell S3D2. Then find the minimum of the rim values 8 and 18. Minimum is 8. So we will allocate the value 8 to the cell S3D2. This satisfies the entire demand of D2 and leaves 18 minus 8 equal to 10 units with S3. Then the rim value corresponding to D2 becomes 0. And the rim value corresponding to S3 becomes 10. So we will get the next table, that is table 1. From table 1, we can see that the column D2 we can strike out and we can form the next table using the remaining rows and columns. From the remaining rows and columns, see the least cost occur in which cell. Least cost is 10, that is in the cell S1D4. That is, from table 1, the smallest transportation cost is 10, which is in the cell S1D4, as we mentioned above. The maximum value which can be allocated to the cell is 7. That is given by the minimum of 7 and 14, that is 7. So we can give the maximum value 7 to the cell S1D4. This exhausts the capacity of S1 and leaves 14 minus 7 equal to 7 units with D4. Then we can form the next table, table 2. So the rim values corresponding to S1 is 0 and corresponding to D4 is 7, and we can strike out the row corresponding to S1. From the next table, with the remaining rows and columns, find the smallest transportation cost, which is 20, which corresponds to the cell S3D4. The smallest transportation cost is 20 in the cell S3D4, as we mentioned above. Then maximum which can be allocated to the cell is 7. This exhausts the capacity of S3 and leaves 10 minus 7 equal to 3 units with D4. So using the remaining rows and columns, we can form the table 3, which is shown here. From this table, see the next smallest transportation cost, which is 40, that is in the cell S2D3. Then the maximum which can be allocated to the cell is 7. This exhausts the capacity of D3 and leaves 9 minus 7 equal to 2 units with S2. The smallest transportation cost is 40 in the cell S2D3, as we said above. The maximum which can be allocated to the cell is 7. This exhausts the capacity of D3 and leaves 9 minus 7 equal to 2 units with S2 as we have seen above. Next, using this information, we can form the table 4. From the remaining rows and columns, see the minimum transportation cost, which is 40, that is in the cell S3D1. Then the maximum which can be allocated to the cell is 3, that is the minimum of the rim values 3 and 5. This exhausts the capacity of S3 and leaves 5 minus 3 equal to 2 units with D1. So we will get that table 5. From table 5, you can see that the smallest transportation cost is 70, that is in the cell S2D1. The maximum which can be allocated to the cell is 2, that is a minimum of 2, 2. Therefore, we can form the table 6. The table 6 is as shown below. See all the rim values, they are all equal to 0. Therefore, the final allocation table is as shown here. From the table, the minimum total transportation cost equal to 10 into 7 plus 70 into 2 plus 40 into 7 plus 40 into 3 plus 8 into 8 plus 20 into 7, that's equal to 840. Here the number of allocated cells equal to 6, which is equal to m plus n minus 1. So the solution is a non-degenerate solution.